Most people believe this. If we can make oxygen on Mars, we can survive. It sounds logical. It sounds simple. NASA tested that idea, and the answer was no. Oxygen alone is not enough. Let me show you why. Let's rewind. In episode 1, you saw what happens without a spacesuit. Death in seconds. In episode 2, you learned Mars isn't almost Earth. It's a frozen radioactive desert, wrapped in carbon dioxide. So naturally, the first question everyone asks is, if I just bring oxygen, can I breathe? On Earth, oxygen means life. Every breath you take, every cell in your body depends on it. So when we talk about Mars, the instinctive question becomes, can we get oxygen there? That question led NASA to one of its most important experiments. But before we go there, you need to understand one invisible rule of human biology. NASA and ESA human physiology research confirms something critical. Oxygen only works when pressure exists. Your lungs don't absorb oxygen just because it's present. They absorb it because pressure forces oxygen molecules into your bloodstream. On Earth, atmospheric pressure is about 101 kilopascals. Under that pressure, oxygen diffuses efficiently into red blood cells. On Mars, surface pressure is around 0.6 kilopascals, less than 1% of Earth's pressure. Even if Mars had oxygen, your blood would still fail to absorb it. It's like trying to drink water through a straw, while the straw has thousands of tiny holes. This is why astronauts don't wear oxygen masks. They wear pressurized suits. We think oxygen equals life. But on Mars, oxygen without pressure is like a parachute without gravity. Completely useless. Mars doesn't just lack oxygen. It lacks the physics that make oxygen usable. So NASA asked a smarter question. Can we manufacture oxygen on Mars? In 2021, aboard the Perseverance rover, NASA deployed a device called MOXIE. MOXIE stands for Mars Oxygen In Situ Resource Utilization Experiment. Its mission was revolutionary. Take Martian carbon dioxide, use electricity, split it into oxygen and carbon monoxide, and it worked. MOXIE successfully produced oxygen on Mars. For the first time in human history, humans made breathable oxygen on another planet. But here's what NASA clearly stated. MOXIE produced oxygen in grams, enough to prove. The chemistry works, enough to demonstrate feasibility, not enough to keep a human alive. A single astronaut needs around 840 grams of oxygen every day. A real Mars habitat would require tons of oxygen, produced continuously with zero system failure. MOXIE proved a concept, not a life support solution. NASA, ESA, and SpaceX agree on one thing. Survival on Mars requires systems, not shortcuts. That means pressurized habitats, fully pressurized suits, redundant oxygen production, continuous pressure control. SpaceX's Starship design reflects this reality. Earth-like internal pressure, closed-loop life support systems. Oxygen is part of an ecosystem, not a miracle. Oxygen is necessary, but pressure is what makes it powerful. Here's the shift most people miss. Mars doesn't ask, do you have oxygen? It asks, can you recreate Earth's environment? Without Earth, survival isn't about one element. It's about systems thinking. Mars punishes simplicity and rewards engineering. So where are we now? With oxygen production and pressurized systems, human survival on Mars rises to 10%. Still fragile, still dangerous, but no longer impossible. In the next episode, we face the next deadly truth. Mars has water, so why can it still kill you? This is Surviving Mars, and we're just getting started. If this changed how you think about Mars, subscribe. Because surviving another planet requires more than hope. It requires understanding.